we have a coil running transverse to the plane of the board that extends a long distance in both the direction coming out of the board and the direction going into the board. In the plane of the board, we have two resistors connected by wires into a loop and two voltmeters with the negative terminals both connected to this point and the positive terminals both connected to this point. We pass a linearly increasing current through the coil, and that induces a constant current in the loop and a discrepancy between the two voltmeter readings. In fact, one of them will be positive and the other will be negative. Now, many people believe that the right way to think about voltages in this circuit is to regard the component of the electromagnetic field along the wires that comes from the changing current in the coil as constituting a secondary transformer voltage along the wires that should be treated the same way that we would treat the source voltage of a battery, such that in particular the total voltage along this path is the same as the total voltage along this path. Now, some people on the internet have pointed out that if that is the right way of thinking about this circuit, then presumably just adding electromagnetic shielding around the four wires that connect to the voltmeters will make the two voltmeters read approximately the same value. Well, I'm quite sure that is not what will happen. In fact, I think that the shields will make virtually no difference to the voltmeter readings. But nevertheless, I think it would be really nice if someone did the experiment with the shields and recorded themselves doing it and uploaded the results to YouTube. By the way, there is actually no such thing as the secondary transformer voltage along a path of circuitry. When we talk about the secondary voltage of an ideal transformer, what we mean by definition is essentially what a voltage measuring device connected across the secondary coil would read if there are no changing magnetic fields besides those inside the transformer. And if you in any way try to apply that concept to this circuit, you will not get a voltage value from this point to this point that is the same going via the left half of the circuit as going via the right half of the circuit.